This is section 10.4. This section has a lot in it. A lot. By now you guys have probably picked up on the fact that I write up the lecture notes ahead of time to make it a little faster for the videos. Look at this, 18. That is insane, the amount of stuff that's crammed into this. So I'm going to split this up into 3 sections. We're going to do the measures of central tendency, then we'll do a separate video for the measures of variation or spread, and then we'll do a separate video for the measures of position and the normal distribution, because there's a lot. Okay, so let's start off with the measures of central tendency. Once data are collected, 2 important aspects of it are center and spread. So a lot of times we're interested in the typical or the average, of a certain data set. That typical or that average is what's called a measure of central tendency. Now, the 3 most common measures of central tendency are the mean, the median, and the mode. Okay? So we're going to handle these one at a time, and then we will calculate them all together on one example. The mean. This is probably the one that you are most familiar with. Typically, the mean and the word averaged are used interchangeably just because this is so common for a measure of central tendency. The mean, we usually use a bar over it. Okay, so that's red X bar. And the mean is just the sum, or add up all the data points and divide by the number of data points. So that's what the mean is. Now the mean is actually a balance point for the data. Okay? Now what that means is that if you can imagine like a seesaw, and you've got kids of different weights at different locations, that if you have a really heavy kid over here, and then you have some lighter kids in here, and maybe one out here, where is that point where that seesaw will balance? So that balance point takes into consideration the data value itself and how far spread out it is. Okay? It is very much affected by something called outliers or extreme values. The median is just the middle of the data when it's in order from least to greatest. That's important. It has to be ordered, and it's usually from least to greatest. You cannot just find the middle of the data set without it being in order. Now, you got to consider something here. If the number of data points is even or odd, where the middle is going to change. If the number of data points is odd, then the middle is going to be one of the data points. If the number of data points is even, you're going to have to average or take the mean of the middle 2 data points. Okay? Now specifically, if you want a formula for this, you can find the middle term if you have an odd number of data points by dividing n, that's the number of data points total, by 2 and rounding up. It's going to be an odd number, so an odd number divided by an odd number divided by 2 is going to give you a decimal, so you just always go ahead and round up, and that'll tell you the term number. And I'll show you this in this specific example. If it's even, the 2 middle terms that you're going to find the mean of is going to be the n over 2 and the n over 2 plus 1 term. So the n over 2 is the one we just found there. So it's going to be that one and the next one that you're going to take the mean of to add up and divide by 2. Now the median is not as affected by outliers. That's why the median is often used to describe salary and home prices. If you see something that says the average salary in a company or the average home price in a city, it's typically the median because there are outliers. There's these houses that sell for, a few $1 million. Okay, we can take those out. Or we have houses that are, in foreclosure, run down or something that are selling for an insanely low price. So we don't want those prices to affect it. We want something that's actually going to give us a typical, number here. And lastly, for measures of central tendency, we have the mode. The mode is the easiest one by far. It is just the data point that occurs the most. So mode, most. Now, unlike the mean and the median, a data set can have more than one mode. It can also have no mode. Okay? It has no mode. This occurs when all of the data points occur the same number of times. Now, the mode is most useful when you have categorical data as opposed to numerical data. You know, if you're talking about something like shoe size, you probably don't want to average that, right? If you're talking about the typical shoe size, the mode would be, the best measure of central tendency. Now, you have to be careful when using the mode to represent average or typical, because the data point that occurs the most may be an extreme value. It may be like one of those super high numbers or super low numbers and may not represent the typical data point of that data set. All right, so let's look at some examples here. Let's choose the best measure of central tendency. Now we're going to pick between mean, median, and mode. There are other measures of central tendency. There's like the mid-range. That's the other one comes to mind right now. But yeah, we're just going to focus on mean, median, mode. Okay, the average home price in a city. When we talk about salaries or home prices, we almost always use the median because it's not as affected by outliers. So that brings us down here. I'm just going to jump down here. The average nurse makes $80,000 per year. That's a salary. That's most likely a median. All right, let me jump back up here. The typical dog breed preferred by people aged 65 and up. All right, this is not numerical data. This is categorical data, right? Because we have categories, breeds of dogs. So when it comes to categorical data, the mode is the best measure of central tendency. So it's categories as opposed to numerical data. All right, and then C, the average age of a university president. The mean would be the best measure here because we're probably not going to have any really extreme values here. We're not going to have someone aged 14 as a university president. We're probably not going to have someone aged, 107. So all those numbers are probably going to be all, kind of close together, not too spread out. So the mean would work well for that. All right, let's find the mean, median, and mode of this data set. So here's the data points. And to save us some time, I went ahead and did the calculations. So first one, the mean. For the mean, we add all of these up and we divide by how many there are. Add them all up, divide by the number of data points. So I added all these up and I got 48. There's 11 data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 48 divided by 11 is about 4.36. Are you guys familiar with the little wiggly equal signs? That means approximately equal to. The median. First thing, put them in order, then find the middle. So I put them in increasing order. Now the middle, so watch. So look, let's start on the ends here. So we have this. Let's move in one. Let's move in another one. Move in another one. Move in another one. Move in another one. Boom, we met right here in the middle. There's the middle. So 2 is right there in the middle. That's the median. Now, the number of data points here is odd. There's 11 data points. So remember over here where I said that if the median was, if the number of data points was odd, then the median was n divided by 2 and round up. So n divided by 2, that's 11 data points, divided by 2 is 5.5, round up. The sixth term is the median. So look, 1, 2, 3, 4, 5, 6. It doesn't mean 6 is the median. It means that's the sixth term. That's helpful if you have a really big fat data set and it's too complicated to do that whole, moving in. But if you don't have too big of a data set, yeah, you can totally just kind of count your way in. All right, the mode. The mode is the number that occurs the most. Now, I have my mode listed as 0. Does that mean that there is no mode? No, it means that 0 is the number that occurs the most. If there was no mode, I would write the word no mode. Now, you may say, well, 2 occurs twice, so isn't it also a mode? No. This one occurs the most. It's not just about listing out all the numbers that are repeated. It's about what number occurs the most. Now, if 0 and 2 both occurred twice, the same number of times, then yes, it would be bimodal, meaning it has 2 modes, 0 and 2. But because 0 occurs more times than the 2, the 0 is our mode. Alright, this is a good opportunity to pause the video. Let's find the mean, median, and mode. And then let's talk about which one best represents the data. Okay, so for the mean, you add them up and you divide by the number of data points. So I went ahead and did this real quick. I just paused the video and did it real quick. I got 3241 over 16. Actually, I did it wrong the first time. So when I went back and checked my answer, I saw that I had made a mistake. So that's why you can see that little, correction tape on there. So what you want to do is you want to be careful, especially when you're adding up a whole bunch of numbers. Check and make sure that you have them all. So when I did this on my calculator, I checked every number against the list, and that's how I figured out that I had messed up when I did my original computation. All right, so the mean is just the sum divided by the number of data points. These are home prices, so this is money here. So next up is the median. Now we know there's going to be an even number of data points here. But first thing we got to do for the median is put the numbers in order from least to greatest. So we're going to put it in order, then find the middle. Now if you want to go straight to the mode, since it's so easy, if you want to do the mode first, then the mean, then the median, I don't blame you. It really doesn't matter which order you do these in. So, all right, so pause the video. I'm going to pause it. I'm going to go ahead and put these in order, try to save us a little bit of time. Okay, so here is the median. I put those in order. Because I knew with 16 data points, I knew good and well I wasn't going to be able to fit those on one line. So I did it to where I increased, going down, 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 down. So those are my increasing order. Now you start trying to work your way in. So there's the end. Move up one. Move inward one again. Move inward one. Move in one. Move in one. Move in one. Move in one. So we end up, because it's an even number of terms, the median is the mean of these middle two terms. So you add them up and divide by 2. So add these up, divide by 2. Really, it's just, look, the mean of these two numbers that are next to each other is the midpoint. So you add them up, you get, and divide by 2, you get 172.5. If you wanted to go back to that little nifty thing that I told you back here, if the number of data points is even, then the mean of the n over 2th and n over 2 plus 1th terms will give you the median. So I just did that real quick and I highlighted it so that it connected to this highlighting back here. So 16 data points divided by 2 is 8. So the 8th and 9th terms are the ones that are going to give you the median. That's the ones you have to find the mean for. And lastly is the mode. Now once you get these in order, that's why I kind of like to do the median first, because then I already have them in order, but you certainly don't have to. The mode is the number that occurs the most. So it's easy to see once you have these in order that there's only one number that's a duplicate, and that would be 425. Now, which one of these is the best measure of central tendency? If you were looking to buy a house in this area, which one of these do you think best represents the typical home price? If somebody said, oh, you should totally live in my neighborhood, the average home price is what? Well, looking at the data up there, which one of these seems to be more typical? Well, I mean, it looks more like the 172.5, doesn't it? I mean, look at these in order. Most of the home prices are under 200,000 because these are the home prices in thousands. So this median seems to actually be the most accurate one. There's only a couple of them that are over 200,000. The mode is definitely not it. Right? There's only 2 of these, and these are extreme values, so it's definitely not the mode. So I would say in this case that the median best represents the data. Although I could see where you might say, either one of those, but I think this one best represents all of that data there. Okay. For this one, let's just find the mode. Well, I'm not going to find the mean or the median. Let's just find the mode for this one. So let's pause the video, see if you can find the mode for those data sets. You don't have to have it in order to find the mode. Okay? It's just the number that occurs the most. All right, so immediately I see that there's 2 15s, but there's also 2 25s. There's only 1 4, 1 6, and 1 32. So this is what's called bimodal. So we say 15 and 25 are both the mode. Unlike means and medians, they only have one answer. Modes, you can have more than one answer. This is what's called bimodal. All right, what about this list? 5, 10, 15, 20, 25, 30. Every number occurs the same number of times. So there's no mode. So since each number occurs, so there's no mode for that one. Don't put 0. 0 is a number. Don't put 0. Remember, as we saw back there, that you can have a mode of 0. Way back here, you can have a mode that's 0. So don't put 0. Put the words no mode. All right, example 5. Is it possible to have a data set where the mean, median, and mode are all the same number without that data set being that number repeated? Like if we say, hey, is it possible for the mean, median, and mode to all be the number 30? Yeah, I mean, if you have a data set of 30, 30, 30, 30, 30, 30. Well, yeah, we can construct a data set where the mean, median, and mode are all the same number. So let's decide on what number we want that to be. How about we say, well, I said 30, right? So let's pick 30. So 30. Since we want the mode to also be 30, I'm going to go ahead and repeat that number. Let me go ahead and just repeat it another time just to be safe. We want this 30 to be the middle number. So however many numbers I add up here, I'm going to add the same number of ones down here. To keep the mean the same, I need this to remain the balance point. That means if I add, let's say, I'm just going to add a data point up here. How about we say 40? So I increase that by 10. To balance out that increase of 10 and keep this the balance point, I'm going to decrease this one by 10. so that now everything's balanced around 30. It occurs more than one time, or sorry, it occurs the most number of times here. It is the middle number, and if you add these up and divide by 5, you're going to get 30. So why did I put 3 of those here? I did that to make sure that the mode was going to be 30. I put 30 in the middle to make sure my median was going to be 30. And then I just picked a number. I just picked a nice number. I could have picked anything. I could have gone up by 2 and put 32, and then down by 2 and put 28. But in this case, the mean, the median, and the mode are all 30. Okay, so that does it for measures of central tendency. So I'll tell you what, this is only 20 minutes. Let's go ahead to the measures of spread, or measures of variation, instead of making another video. Let's see if we can zip through this one. Knowing the center of the data is not enough to get a full picture of the data. Okay, so we're interested in both the center and how spread out it is. Now we're going to talk about 2 measures of spread. The range, which is the easiest because it's just the highest minus the lowest. Okay, not very helpful when it comes to having extreme values, because then it gives you a really wide range. Especially if you have extreme values on both ends, right? Then you have, a distorted range. So instead, a better measure is going to be something called the standard deviation, which we're going to get to. Your book takes a little deviation of its own here. The interquartile range. Okay? That's another measure of spread. And this is actually most helpful in telling us how spread out certain quartiles are. The median of a data set splits a set of data in half. The median of the lower half is called the lower quartile. Now the word quartile is because we're splitting this data into fourths, right? The word quart implying fourths. The median of the upper half is called the upper quartile. We use Q3. So we use Q1 for the lower, Q3 for the upper. That's because the mean is Q2. That's the middle quartile there. The interquartile range is just the upper minus the lower. This tells us how spread out the middle 50% of the data values are. We can visualize this spread by drawing something called a box plot or a box and whisker plot. Okay. So let's draw one of those. You'll notice I've already got my data points in order for us. That's going to make it super duper helpful to find our median, our lower quartile, and our upper quartile. So let's start with the median here, the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Good. Odd number of data points means that the middle number is a single number and we don't have to take the mean of 2 numbers in the middle. So let's find the middle number here. So boop, there it is. There's our median. All right, now let's find our lower quartile. The lower quartile is going to be the median of the lower half of the data. So just isolating that lower part of the data, what's the median? Well, there's 1, 2, 3, 4, 5, 6, so we're going to have to take a mean of the middle 2. So which middle 2? These 2. So 40 plus 50 divided by 2